the Fourier series, find the Fourier series for f of x which is equal to 0 minus pi less than x less than 0, x 0 less than x less than plus pi. So find the Fourier series for f of x is equal to, two values are given. So we have to check. So what is given? Given one is f of x is equal to, the two values are given, minus pi less than x less than 0, comma x 0 less than x less than plus pi. So what we have to check, whether the given function is even or odd. So how to check, I will tell you. F of x is equal to, first one you have to take phi 1 of x minus pi less than x less than 0. Second one is phi 2 of x 0 less than x less than plus pi. So phi 1 of x, phi 2 of x. What is the phi 1 of x? Phi 1 of x is equal to 0, that is given in the problem. If you are comparing phi 2 of x which is equal to x, that is also given in the problem. So here you have to take phi 1 of minus x is equal to, phi 1 of minus x is equal to phi 1 of minus x is equal to, that is 0. If you are adding minus sign, it will become a 0, which is not is equal to phi 2 of x, which is not is equal to minus phi 2 of x. If it is equal to phi 2 of x, that is even function. If it is equal to minus phi 2 of x, that is called as odd function. So here the given function is f of x is neither even nor odd. So neither even nor odd function. So neither even nor odd function. So therefore we have to solve as usual. So as usual, if you are solving this, f of x is equal to, f of x, the Fourier series f of x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. So this is a formula. So we have to find the value of a0, value of an, value of bn. So a0 is equal to 1 by pi integral 0 to pi f of x into dx. But here the original formula is minus pi to plus pi. So you have to write minus pi to plus pi. So here the value of minus pi to 0, you can divide into two integrals, minus pi to 0, that is given in the problem for f of x, 0 into dx, plus integral 0 to pi for f of x, x into dx, which is equal to 1 by pi 0 to pi. First term will become as 0. So second term will become as 0 to pi x into dx. So x, if we are integrating, x square by 2. The limit is 0 to pi. So therefore, if you apply for x which is equal to pi, so which is equal to 1 by pi. So pi square divided by 2. So pi square will be cancelled. So answer is pi by 2. So a0 is equal to pi by 2. Okay, so this is the answer. a0 is equal to pi by 2. Next you have to find the value for an. An is equal to 1 by pi minus pi to plus pi f of x cos nx into dx. So f of x cos nx into dx. So f of x value is minus pi to plus pi. So what is the f of x value? Two values are given. So 1 by pi. So minus pi to 0. F of x is 0 cos nx dx plus integral over the limit 0 to pi f of x is x cos nx dx. So you got to use the Bernoulli's formula. So first one will be cancelled. So 1 by pi. So integral over the limit 0 to pi x cos nx dx. So you have to use the Bernoulli's formula. What is the Bernoulli's formula? Integral uv dx, which is equal to uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4. So u is equal to x, v is equal to cos nx. So what is u dash? Which is equal to differentiation. X, if you are differentiating, you will get 1. Next you have to differentiate u double dash. U double dash will become as 0. So therefore u double dash, which is equal to 0. v1 is equal to cos nx. You have to integrate. If you are integrating, sin nx divided by n. v2 is equal to minus cos nx divided by n square. So you got to use the Bernoulli's formula, which is equal to 1 by pi integral over the limit 0 to pi. Here you got to use uv1. So x sin nx dx minus u dash 1. v2 is minus cos. So that's why plus cos nx divided by n square. Limit is 0 to pi. So for x you got to apply the limit 0 to pi. So therefore it will become, which is equal to 1 by pi. For x pi, so pi upper limit sin n pi plus cos n pi divided by n square. It is up. This is upper limit. For lower limit, minus 0 sin 0 plus cos 0 divided by n square. This is upper limit as well as lower limit, which is equal to 1 by pi. This is an sin n pi 0, sin 0 0. So you will get only cos n pi divided by n square minus cos 0 is 1 divided by n square. So n square is common. An is equal to 1 by pi n square. Cos n pi can be written as minus 1 power n minus 1. This is an value. So as well as you can find the bn value. So bn is equal to, same formula you got to use. The formula is different. So bn is equal to 1 by pi integral over the limit minus pi to plus pi f of x sin nx dx. So f minus pi to plus pi can be divided into two parts, two integrals. So minus pi to 0, f of x is 0 into sin nx plus dx plus 0 to pi f of x is x sin nx into dx. So therefore which is equal to, first term will vanish. So second term will be 0 to pi x sin nx dx. So again you got to use the Bernoulli's formula. The Bernoulli's formula is 1 by pi so integral, I am writing the Bernoulli's formula, uv dx is equal to uv1 minus u dash v2 plus u double dash v3. So u is equal to x, u dash is equal to 1, u double dash is equal to 0. V is equal to sin nx. v1 is equal to minus cos nx divided by n. v2 is equal to minus sin nx divided by n square. So uv1 minus u dash v2. So therefore you got to use, so bn is equal to 1 by pi minus x cos nx minus of sin nx will be plus sin nx by n square. Here will be divided by n, 0 to pi. So second term will vanish. So first term will become as 1 by pi minus pi cos n pi divided by n. Minus of minus plus 0 into cos 0 will become as 0. So plus pi minus pi cancel, minus 1 by n minus 1 power n. This is the bn value. So substitute a0 an bn value in the Fourier series formula. So what is the Fourier series formula, you have to substitute A naught, An, Bn value. So what is the A naught value? A naught value is f of x is equal to A naught by 2. So pi by 2 divided by 2 plus summation n equal to 1 to infinity An. An is 1 by pi n square minus 1 power n minus 1. This is An value plus Bn value, which is equal to minus 1 by n An cos nx plus Bn sin nx minus 1 power n sin nx value. This is cos nx sin nx. This is the final answer.